in this case, we've got Na₂SO₄, and we've been told the mass of the hydrated sample as well as the mass of the anhydrous sample, and we've been asked to figure out, well, what's the value of x? So what's the value of this the coefficient next to H2O, right? So how are we going to go about working this out? Well, you can see in the format that we've got here is that we've got effectively for every 1 mole of Na₂SO₄, we've got x moles of H2O, right? And that's the comparison we've got. So what we want to be able to do is compare the actual number of moles of each. And currently what we have mainly is masses, right? So if we can try and get the masses we have and convert those to molar values, we would be able to then make a comparison, right? So what I'm going to do is, in this instance here, we've got the anhydrous mass. So this relates to effectively the mass of Na₂SO₄ we've got in the sample. So I'm going to use the equation that relates the mass, moles, and molar mass, right? So I'm going to, that's the number of moles is equal to the mass divided by the molar mass, mR, right? And in this case, the mass is going to be, well, I'm going to make this clearer because we're going to be doing some other mole calculations, but the number of moles of Na₂SO₄ is going to be equal to, yes, we can just kind of separate this, is going to be equal to 9.55 9.55 divided by the molar mass of the Na₂SO₄. So we can work out the molar mass through the periodic table, right? So Na₂SO₄, that's going to be, so you've got 23, so that's going to be mR of Na₂SO₄. This is going to be 23 times 2 plus, so for S it's going to be 32.1, right? And then for O4 it's going to be, so you add 16 times 4, 16 times 4, right? And that's going to give us the molar mass for the Na₂SO₄. And if you have a go at working now, what you should find is you get 142.1, and that's going to be in grams per mole, right? Now, this is the molar mass for Na₂SO₄, so what we can do is put this in here, so 142.1, right? And this is going to give you the number of moles of Na₂SO₄, right? So if you do work that out, you should find that you get 0.067206, and that's going to be in moles, right? And similarly for the H2O, we need to work out the number of moles of H2O. We haven't been explicitly given what the mass of the H2O is, but we can effectively work that out because what we have been given is the hydrated sample's mass and the anhydrous sample's mass. So simply, if we do the hydrated sample mass minus the anhydrous sample mass, we would effectively work out the mass of H2O that was present in the hydrated sample, right? So in this case, that's 20.89 minus 9.55, right? And that's effectively going to give you what the H2O mass is going to be. So that's going to be 11.34, okay? That's going to be in grams. Now, with this value in mind, we can say, okay, well, using the same equation that we have here, in terms of the number of moles for H2O, that's going to be equal to 11.34 divided by the molar mass for H2O. So you may know this, but if you do quickly work this out from periodic table, that's going to be simply, it's going to be for the hydrogen, it's going to be the 1 times 2, right? So this is Mr of H2O, right? 1 times 2 plus 16, right? Which is going to, of course, going to be 18, and that's going to be in grams per mole, right? So in this case, it's going to be 11.34 divided by 18, right? And if you do work that out, you should find that you get 0.63, right? And that's going to be in moles. Okay. Now, one of the things at this stage we're going to do is we're going to set up a ratio. And because, as you can see in this equation, we've got Na₂SO₄ on the left-hand side, we're going to put that the moles corresponding to that on the left-hand side in the ratio, right? So what this ratio is effectively a ratio between the number of moles of Na₂SO₄ and the number of moles of H2O, right? And you can see the value of trying to make this comparison because of how this is set up here. Now, and there's going to be a few more points to draw from that. So for H2O, as we worked out, it's going to be 0.63, right? For Na₂SO₄, it's going to be, as we worked out as well, 0.067206. Now, drawing the additional point from this is the fact that, as we discussed, the coefficient for the Na₂SO₄ is effectively 1, right? So because it's 1, what we want to do is get the molar value corresponding to it here in this ratio also to be 1 on the left hand side. And of course, the way we can do that quite straightforwardly is dividing it by itself. So divide that by 0.067206, right? And because it's a ratio, we want to what we do to that left hand side, we also want to do it to the right hand side, right? So the 0.63 also, we want to divide that by 0.067206, okay? And effectively what we're going to get here is going to be 1 on the left hand side, and on the right hand side what you should find is that you get 9.3742, right? Now, what I'm going to do at this stage is I'm going to round the value of this to the nearest integer value, which in this particular case is going to be I'm going to be rounding it down. Okay, so effectively that's going to be 1, and it's going to be in a ratio of what approximates to 9 after we've rounded it, right? And on that basis, I'm able to say that actually the value of x is 9, right? So I'm going to say, well, the value of x is 9, right? So that's going to be effectively Na₂SO₄.9 H2O, right? Using the value of x that we've just determined. All right.